Perfect. Good morning, everybody. Really excited to talk to you. Today, I wanted to spend my time talking about what I think is, I want to talk about what I think is impactful in Web3. And specifically, I was really trying to figure out what was going to happen in data broadly in 2024. And in the journey of trying to look at several different topics, obviously, I gravitated towards everything happening in AI. And I settled on presenting this topic, which I think is perhaps the most underappreciated trend in AI right now. I think most people are underestimating how far it is and how far it's going to go over the next 12 months. And I think it's at an inflection point where we're seeing a huge amount of research, a huge amount of value in getting it right, and a huge amount of momentum behind progressing it. I believe synthetic data is the clean energy of the information age. And because of that, it's going to impact every single topic that we're talking about today. So I thought it would be a really fun area to explore with all of you. And I figure most people in the room are aware of the topic of synthetic data and roughly what the intents of building synthetic data is. But maybe I can share with you some ideas behind how it's being created, how far it already is, and what the applications directly in Web3 can be. So starting at the beginning, if you're not familiar with synthetic data at all, just step away from data for a second. And I know everybody in the room has observed the impressive abilities of LLMs. So if you ask an LLM to generate the first line of a new play of Shakespeare, it can create a pretty reasonable result, and with a little coaxing, a quite good result. But the total words in Shakespeare's plays are only 1 million, less than 1 million, I think like 800,000. So where does it get this ability? Well, there's a lot of ways it gets the ability, but generative models in general have been really good at, or what we're getting really good at using these models for, are figuring out the general distribution of these abstract concepts and then creating new information within that distribution. So synthetic data taps into that ability. So what you do is you take a generative model, you train that model using your own data or fine-tune it using your own data so that the model captures a reasonable distribution of the space you're trying to generate new information within. And then you use the resulting model to generate new data. This skips over a lot of the nuance and complexity there, but that's roughly what it is. Take, model, train, or fine-tune it on specific context, and then generate new data within that context. So refining general models, we can make domain-specific models. We can use those domain-specific models to generate synthetic data. But then the power of synthetic data is that we can use it to train models that can learn totally new things and be skilled at extracting new information from our data or making new predictions, for example. And because of the power of synthetic data, I think that it means that all data that we're experiencing on the internet is only the tip of the iceberg for what we're going to see. And that everything below, or primarily what we're going to see the next 10x of data come from, is actually synthetic data. So let me show that to you. I have links for all these projects I'm going to show you in a blog post I wrote, tinyurl, sy data. So the first example of this in action is a research project from Microsoft. So what they did first is they said, okay, well, if you want to build an accurate face tracker, if you want to build an accurate camera that can mark up all of the landmarks on a face as it's moving around the real world, you have like in the 2019 mode, what you do is you'd go collect a lot of imagery, a lot of 3D data from real faces, and then you'd have people go through and put the landmark labeling on all that imagery. But if you want really high scale information about the data about real faces, you need a better model that can do that on a lot more landmarks than what's humanly possible to create. So what this research team did is first they created a synthetic data set of 100,000 3D faces. That the benefit of doing it that way is that they know exactly where the landmarks are because they created the faces. And they could create a much higher resolution of landmarks on that data to then train a model to recognize those landmarks on real faces. So synthetic faces to real facial tracking. Then the next step they did is they said, we can actually use these faces to put real eye movement on synthetic faces. So they did the exact same thing. They took the synthetic faces, they put synthetic eye movement on those faces with pre-labeled information about every place the eye is in space and time. And then they created new models to do eye tracking at scale. Synthetic data is actually blowing up in medical research. So you can think of a number of applications here and benefits of doing it this way, but creating synthetic imagery of real diseases and real things that you want to extract from medical imagery. One of the major there are several things that this can overcome. First, privacy and data. So how do you move medical imagery across research teams due to regulation, due to respect for the patients? One way to do it is actually synthetic data. Instead of having all teams be able to access real data about patients, you have a limited number of people that can train models, use that general distribution to then create a lot of fake data that is highly reasonable, and you can train new models to detect things like cancer. Another reason that it is highly valuable is you can actually use synthetic data to smooth out sampling bias. So a lot of cases where, for example, oversampling of male or female populations in medical data cause real problems for being able to train models. You can actually use the distribution of the smaller sample size to then create synthetic data that has an even distribution to train better models for detecting real medical cases. So this is happening. The quote here I have is from a Nature paper that the proliferation of synthetic data in medical research is actually presenting real problems that they're going to need to confront. But at the same time, the value and the opportunity of doing it is so large that it's going to move really, really fast. So you can think of a number of different ways that synthetic data is useful. So for like the Microsoft research example, being able to scale up your sample size way beyond what is humanly possible. In their case, being able to get the training data with pre-labeled landmarks at a scale that you couldn't pay enough humans to go do from real imagery. Moving around private data in public networks. Here, instead of moving around the real private data, you create synthetic data that has all the value or the value that you need from the private data, but doesn't have those restrictions. Overcoming sampling bias, for example, or upsampling rare events in data that you actually want to train models around. All of these and more are a lot of reasons to see the value in synthetic data, but also the tooling is moving so fast. So, for example, a lot of projects understand that real physics simulators are a bottleneck right now. Why? Because you can use real physical environment or simulated physical environments to create massive scales of synthetic data, for example, for training robotics. There's a number of startups that are working on helping you create synthetic data from your existing data. So you can think of like using time series data, using one of these packages of tools and creating new models that then can generate synthetic data for prediction, for simulation, for lots of other things. And I think one of the most interesting ways to think about synthetic data is using one of these large foundational models and then extracting all of the context from it into specific models that are really good at creating synthetic data for you. But there's a lot of nuance to actually doing that, so I'm gonna brush over that. But I want to talk about, for everybody in this room that's working in Web3, how is synthetic data going to impact the projects that we're working on? What's the opportunity and what are the benefits? I think I've been to like 3 really big DeepIn events this week, and I think that that community has a huge opportunity to tap into the benefits of synthetic data now. And I put that roughly under the category of bootstrapping data economies. So a project that we work closely with, WeatherXM, is a great example of a project that could tap into this with some investment and work. WeatherXM, they collect global weather data from stations installed around the world. They've been around for a number of years. The stations are growing. However, how do you build models on that data that can detect rare events? For example, heat waves, tornadoes, hurricanes, floods, all of that data that you see rarely in that data, and because the network is still small and growing, has been seen even less frequently in the type of data they collect. Synthetic data can actually help them create those data sets before they exist at scale, and then build models and automation on top of those events when they're detected. So in a way, being able to bootstrap all the innovation on the data alongside the bootstrapping of the actual network that's collecting the real data. So fake it until you make it. You can see it in cases where Web3 is trying to build standards and interoperability around private data for the exact examples I gave you in medical research. Private data can't be moved across Web3 pipes so that all projects can build models, agents, all that good stuff on top of it, but synthetic data can. A lot of other examples. The other reason I think synthetic data is really powerful for this community, the second opportunity, is democratizing access and innovation. So for the same reason, being able to use foundational models to create synthetic data that people can actually build innovations on top of right now. If you want to come to Web3 and you want to build agents, you want to build advanced models, where's the substrate of data? How are you going to access it? We can actually use synthetic data to get there very quickly. Collaborating on open synthetic data, I believe, can drive innovation and distribute it to teams across the world without having that lock-in of single organizations needing to own it because it's some sort of private and highly valuable data. I think the third opportunity is something that Vitalik hit on in his crypto and AI blog post, which is that blockchain is really good at storing and verifying data. This data is going to cause a real problem on the internet, and I don't doubt that over the next year, 2 years, we're going to see a number of cases where synthetic data mixes with real data unintentionally. So whether that's one way, real data coming out when people actually thought it was synthetic data, or leaking real data in the models they create that are intending to create synthetic private data, or inversely, people actually feeding synthetic data into real systems in order to trick the real systems that aren't prepared for it. But I think blockchain can actually step in here in giving us the tools to create authenticity, accountability, provenance, and verifiability around the data sets that we're creating. And this is something that we work on quite a lot on my project. So how do we scale, connect, and mobilize this data, maintaining that provenance, maintaining the attribution, and all that good stuff. You can check out a couple of our products, our database at Tableland XYZ, and our latest product that we're working on, the object store, at our textile website. Sam Altman said almost 10 years ago that the ARC technology was about reducing randomness, but in reflecting on where we were going with AI, that we were going to inject the most randomness we've ever seen in the system. Synthetic data is a big piece of that. Everything that we've thought about the truthfulness and verifiability of raw data is about to go away. Gartner thinks that by 2030, the majority of data in AI is going to be synthetic data. So the major unlocks of GPT-4 are not going to come from entirely new sources of data as much as they are going to come from honing and perfecting our ability to create synthetic data to train new skills in AI. I think for specialized models and specialized domains, like the ones that I gave you in Web3, this is going to move a lot faster. So this is the thing I think you all should be keeping an eye on over the next 12 months. I think it's going to change everything, and all of the conversations that we're going to have for the rest of the day are going to change in reflection to synthetic data becoming real. Thanks.